Hi everyone, my name is V. Ramakrishna. I have been teaching mathematics for JEE Advanced for 20 years. I have produced many ranks in both IIT as well as NITs. Till now, more than 1,000 students of mine have finished their graduation in NIT and IITs. According to my observation, in the recent years, UPSC have been changing the difficulty level of CSAT exam. So in viewing that, I would like to give my teaching abilities, explanations in a easiest way so that UPSC aspirants can utilize my lectures. I'm going to start permutations and combinations. Usually people may feel that permutations and combination is a very difficult topic. Of course, it is difficult if we go in depth. But the beginning of permutations and combinations does not require any formulas. Only a basic logic is required. Almost all, each and every question of CSAT can be solved without using formulas of permutations and combinations. If we have a little logical thinking, then immediately we can solve almost all each and every questions, maybe except a few questions. They are little lengthy and we may feel difficult in understanding the question in the stipulated time. So before going to explain what is permutation or what is combination, I will explain what is factorial. After that, I'll explain what is a multiplication rule and what is an addition rule and how these rules can be applied in the arrangement of objects. What is meant by a zero factorial? So zero factorial can be defined as 1, right? We define that 0 factorial equal to 1. This is nothing but factorial symbol. Factorial symbol. Of course, this factorial symbol can also be represented as like a L shape. Okay. So this I can write 0 factorial. 1 factorial. 1 factorial equal to 1. 2 factorial. You start from 2 and goes up to 1. 2 into 1. 3 factorial. It is nothing but start from 3, decrease 1 by 1 until you reach 1. 3 into 2 into 1. So this is nothing but product of 3 consecutive natural numbers. First 3 consecutive natural numbers. Similarly, 4 factorial equal to 4 into 3 into 2 into 1. That's equal to 4 factorial. So this is a product of first 4 consecutive natural numbers. Product of product of first four consecutive natural numbers. Consecutive natural numbers. Now you see, further I can write 4 factorial as 4 into 3 factorial. Or I can write 4 into 3 into 2 factorial. Wherever you want to stop, you can stop by putting a factorial at the end. Okay. So in the similar way, we can define what is n factorial. This is and so on. Now we define n factorial. N factorial equal to, we write n into n minus 1 factorial. I have stopped at n minus 1 factorial. You can continue by decreasing 1 by 1. N into n minus 1 into n minus 2 factorial. If you continue this process by decreasing 1 by 1, you will get n into n minus 1 into n minus 2. You have to go up to 1. This is equal to 1. So this is known as a n factorial. Now, where do we use these factorials? So before I introduce that what is permutation, I will explain what is a multiplication rule and what is an addition rule. When to use multiplication rule, when to use addition rule, and how to recognize that which rule has to be applied when a question comes. Well, so what is a multiplication rule? I'll explain now. Suppose there are two jobs. You can say job or an event or a piece of work, any related work. Suppose job 1 can be done in some m ways, which means a piece of work can be done in m ways. There are several ways to do a piece of work. So first job can be done in m ways. Like for example, I can tell you one example. You take a car, right? You want to paint the car with 3 different colors, right? With 3 different colors. So you can paint the car in 3 different ways with those 3 different colors. Here, the painting the color is a job or a piece of work, and it can be done in 3 ways. Similarly, another job 2 can be done in n ways. Job 2 can be done in n ways. I'll give you another example. For example, suppose a man have 3 shirts and 4 pants. 3 shirts and 4 pants. He wants to wear a shirt and a pant, right? So wearing a pant is a job 1 and wearing a shirt is a job. So these are the 2 jobs. He can choose any one of the 4 pants. So there are 4 ways to wear a pant and there are 3 ways to wear a shirt. I'm just explaining what is meant by a job or an event or a piece of work. So here, this is a job or work, or you can say an event or an event. We do not bother about those words. Okay, we have to look forward that how do we use this multiplication rule. Now you see, job 1 can be done in M ways, like wearing shirts, and job 2 can be done in N ways, like wearing a pant. Now, the question can be raised, in how many ways a person can wear a pant and a shirt. Here I am using a word and. Here I am using a word and. So that and represents multiplication rule. So now job 1 and job 2, one after another, can be performed in M into N ways. Job 1 and job 2. Here you see job 1 and job 2. Look at the word and. This and indicates that in general multiplication. So job 1 and job 2 can be performed in M into N ways. This is known as a multiplication rule. An action can be done in M ways. Another action can be done in N ways. Now both actions, one after another, can be done in M into N ways. Like an example, that in how many ways a man can wear 3 different shirts and 4 different pants, right? So he can wear any one of the 3 shirts. So there are 3 ways to wear a shirt. There are 4 ways to wear a pant. Now together, these 2 jobs together can be done in 3 into 4. That's equal to 12 ways. I'll write that example. So here is the question, that in how many ways a man can wear 3 different shirts and 4 different pants. 4 different pants, right? Now you see, we have 3 shirts. Let us assume S1, S2, S3. Suppose if you wear a shirt, then you can choose pant 1, pant 2, pant 3, and pant 4. There are 4 ways. So there are 4 ways. These are 4 ways for one shirt. Similarly, here also there are 4 ways. Suppose if you wear a shirt 2, you can wear any one of the 4 pants. For S3 also 4 ways. So you can choose a first case or second case or third case. All right. So we have that totally 4 plus 4 plus 4 equal to, that's equal to 3 into 4. Right? So this is the job 1. And this is job 2. I'm just giving the number job 1, job 2. There is no specifications that which is job 1 and which is job 2. So what is job 1? Wearing a shirt. Job 1 is wearing a shirt. Job 2, wearing a pant. Right? A pant. So now these 2 jobs together can be done in 3 into 4. First job can be done in 3 ways. Second job can be done in 4 ways. Both the jobs together can be done in 3 into 4. That's equal to 12 ways. You can extend this rule up to any finite number of jobs. You can choose 3 events or 3 jobs, 4 jobs, 5 jobs, one after another can be done in multiplication of those numbers. I will give you another question of CSAT 2022 question. I hope I'll bring that question now. Here is a question asked in CSAT 2022. Very basic level question. 2022. Okay, if you understand the question, you won't take more than 1 minute. A, B, and C are the 3 places such that there are 3 different roads from A to B. Well, there are 3 different roads from A to B. And how many routes are there from B to C? From A to B, there are 3 different routes. 1, 2, and 3. And from B to C, there are 4 different routes from B to C. Right. Well, there are 4 different routes. If you are feeling that I am teaching slow, you can listen by putting 1.5 times also. There are 4 different routes. And there are 3 different routes from A to C. There are 3 different routes from A to C. Well, like this. Okay, from A to C. Now you see, this is going from A to B is a job 1. Going from A to B is a job 1. Going to B to C is a job 2. This is a job 2. Going from A to C is another job. It is another job. Now the question is, in how many ways, how many different ways can one travel from A to C using these roads? We have to travel from A to C, right? Now you see, to travel from A to C, you can use the place B or directly you can go from A to C. Here I have used a word or, right? So the number of routes from A to C, start from A, reach B, and then reach C, right? Or whenever R comes, you have to use the sign less. Directly A to C. Directly A to C. Going from A to B, there are 3 routes. There are 3 routes, right? You have to travel from A to B and then you have to move to C. So how many routes are there from B to C? There are 4 routes. I'm using the word end. You have to move from A to B and then B to C. So whenever you are using the word and, you have to consider multiplication. So first job can be done in 3 ways. Second job can be done in 4 ways, right? Or you can directly travel from A to C as there are 3 routes from A to C. These are the 3 routes. So therefore, required ways equal to 3 into 4, that is y of B, or directly you can move from A to C. So this is equal to 12 plus 3 equal to 15. Very simple question. So even though I did not explain what is the addition rule, automatically we have understand that, okay, we have to use the addition rule. In the first case, multiplication. Second, why? You can move from A to B and then C, or from A to C directly. Whenever a word or comes, when we are thinking about the question, immediately you have to use addition rule. Whenever we are using the word and, then you have to multiply the numbers, right? So I'm going to explain what is the addition rule now. I'll give you another example based on the same time. So I have changed that question with a slight modification. Same question. At last, see in how many different ways one can travel from A to C using these roads and written by a different route. And then written by a different route. Written back to A, right? We have to go back to city A or place A, right? So we have traveled from A to C, and when we are going back, we should not use the same route. You have to go back by a different route. You have to go back by a different route. I'll explain now. Well, what is job one? Job one is going from A to C. Going from A to C. There are 15 ways. There are 15 ways. Going from A to C, there are 15 ways, right? Either directly A to C or A to B to C. Together, there are 15 ways. Job 2. What is the job 2? Written by a different route. Written by a different route. Written by a different route. Right? So, as there are 15 ways to travel from A to C, when we go back, we have to use a different route, right? So, which means that among those 15 routes, we have to remove the route which we have used, right? Remove the route which we have used to travel from A to C. Remove that route. Now there are 14 routes are available to go back from C to A. So there are 14 ways. Right? Traveling from A to C is a job 1, and going back to original place is a job 2. Here we are using the word, right? How many ways one can travel from A to C using these roads and written by a different route? There is a word and, right? So therefore, required ways, the number of required ways is equal to job 1 can be done in 15 ways, and then job 2 can be done in 14 ways. Well, this is equal to 210. So there are 210 different ways. I'll explain another example. Suppose there are 5 doors in a classroom. There are 5 doors in a classroom. In how many ways a teacher can enter the room and return by a different door? In how many ways a teacher can enter the room having 5 doors and written by a different door. So there are 5 ways to enter into the room. There are 5 ways to enter into the room. And there are 4 ways to come out of the room, because he has to choose another door which he has used already. So going into the room, there are 5 ways. Coming out of the room, there are 4 ways. So totally, there are 20 ways. I hope you are understanding. Now, what is meant by addition rule? Suppose job 1 can be done in M ways, and job 2 can be done in some N ways. Job 1 can be done in M ways. Job 2 can be done in N ways. Now, job 1 or job 2. Here is a word or. And job 2 is independent of job 1. It is independent of job 1. It is not at all depending upon job 1. Independent of job 1. These two are independent jobs. Right? Job 1 or job 2 can be done in M plus N ways. Right? Which means that the previous one is the multiplication rule, because job 2 can be done after performing job 1, whereas job 2 depends upon job 1. Here, job 1 and job 2, no way they are related. They are completely independent. Like, for example, there are 20 boys and 15 girls in a class. There are 20 boys and 15 girls in a class. How many ways a class leader can be chosen? In how many ways a class leader can be chosen, right? So the class leader can be either a boy or a girl, either a boy or a girl. So if it is boy, you can choose the boy in 20 ways. If it is a girl, you can choose in 15 ways. So together, a class leader can be any one among the 35 students. So there are 35 ways to choose a class leader of a class consisting of 20 boys and 15 girls. Here we are using a word particularly or. We are separating the jobs. We are separating the jobs. I'll write that example. In how many ways one can select a class leader from a class consisting of 20 boys and 15 girls? Here we have to use addition rule. In fact, we do not employ those rules. Without employing those rules, automatically we'll come to know when to use multiplication rule and when to use addition rule. So leader, that leader can be boy or a girl. Leader can be boy or a girl, right? So here I have to use the word or. If it is boy, there are 20 ways. There are 20 ways to select a boy leader. If it is a girl, there are 15 ways to select girl leader, right? So there are 35 ways. Right? Well, what is meant by a permutation? So we will use those multiplication and addition rule to solve any kind of question regarding permutation and combination. What is meant by a permutation? It is just nothing but arrangement of objects. It is arrangement of objects. It is arrangement of objects. These arrangement of objects, you can take all at a time or you can take some of them. Arrangement of objects, taken some or all. Taking some or all at a time. Or all at a time. Means you can take some objects and then arrange, or you can choose all the objects and arrange them. So permutation is nothing but an arrangement of things or objects or persons or letters or balls, whatever it may be, just we have to make them arrange. For example, I'll explain. It is a very simple. For example, in how many ways two persons, right? In how many ways two persons can be arranged along a row. Along a row. Or, for example, I have given A, B. If I give two objects, you can arrange two ways, AB or BA. So we can arrange two ways. There are two ways to arrange two different letters. Well, suppose if I have given three objects, A, B, C. Keep A as it is, interchange B and C. Right? And now start with B. B, A, C. Keep B as it is, arrange A and C. Just interchange A and C. B, C, A. Start with C. C, A, B. C, B, A. So there are 6 ways. There are 6 ways. So there are 6 ways to arrange 3 objects. Arrangement, in the arrangement, order of objects is important. Right here, order of objects is important. In which order the objects appear is considered very strongly. Here, order of objects is important. Whether we are arranging different objects or similar or same kind of objects. Order of objects is important. Well, now, should we write all these ways? What happens if number of objects is 4 or 5 or 6 or etc.? No, we shouldn't at all. There is a very simple logic to arrange the objects that I will use usually box method. I will explain that these two examples using the box method. Well, see, for this, to arrange two objects, I will take two boxes. Well, now in the first box, I can put either A or B. There are two ways. Either A or B. Here, either A or B. There is only one object is left. So I can put that object in the second box. So putting an object in the box is a job one. And putting an object in the second box is a job. Well, this is the box one, this is the box two. So there are 2 into 1 equal to 2 ways. So which means that how many objects do you want to arrange? You take those many boxes. Second example, I want to arrange three objects. I want to arrange three objects. So I have to consider three boxes. Whether you box, join them, or you take them separately, it doesn't matter. Well, okay. So here you see this place, first place, I can put A or B or C. So there are three ways to fill the first place. There are three ways to fill the first place, either A or B or C. In the second place, there are two ways. Suppose if I have kept A in the first place and remaining two objects are B and C, hence second box can be filled in only two ways. Here I don't want to repeat the objects. And now there is only one object is left. So here this is either A or B or C. This is rest of two objects, right? Or you can say remaining two objects. Remaining two letters. And finally, one letter is left that you put in the third box. So this is job one, performed in three ways. And then job two, performed in two ways. And then job three, performed in one way. So this is totally 3 into 2 equal to 6 ways. Now, permutation is over. Whatever kind of question they have given, you can solve using this box method. Whether to form a numbers or whether to arrange the objects or whether to arrange persons or whether to arrange letters, for any kind of question, almost all everywhere you can use this box method. I'll give you one more example. Here is a question of CSAT 2020. Okay, CSAT 2020. I will solve this question. From there onwards, you can solve many number of questions. If you understand this question, really, if you understand this question, no doubt, I am sure that everybody can solve any kind of question. Using the same method almost all. See, how many different five-letter words with or without meaning can be constructed using all the letters of the word Delhi so that each word has to start with D and end with I. Well, question is over. We want to frame five-letter words. Okay. So we have to take the five boxes. Okay. Take five boxes. It generally we should not write anything in the permutations and combinations. Everything is symbolized form. So consider five boxes. 1, 2, 3, 4, 5. Well, you read the question. That word has to start with D. Word has to start with D. So fix the D in the first place. And end with I. End with I. Okay. Fill the last box by I. Now D and I fixed. Well, now there are only three letters left. What are these? E, comma, L, comma, H. Only 3 letters left, right? Now you see, this second box can be filled in 3 ways. Either E or L or H. After filling that second box, there are only 2 letters left. So second box can be filled in 2 ways. Well, now there is only 1 letter is left. So the third box can be filled in only 1 way. That's equal to 6 ways. Question is finished. It's a matter of only 1 minute. Using this example, we can create not less than 20 problems. Like the number of ways of arranging the letters of the word Delhi. Begin with D. That's it. Only begin with D. Or begin or end with I. Right? Neither begin with D nor end with I. Or vowels come together when you are arranging the letters of the word Delhi. All vowels come together. E and I come together. Vowels do not come together. Vowels do not come together. Means vowels must be separated. So all these different kind of questions I'll explain in the next video by taking the same example so that it covers each and every kind of model. Thank you.